for this one is the series that you're supposed to start with, isn't that a lot more obvious maybe than it was yesterday? And it just says cosine, so I think we should start with that. You guys using substitution, algebra, differentiation, or integration? It's another substitution, that's right, yeah. Okay, so just to refresh your memories, get this in front of you again. I'm going to go ahead and write it out here. Cosine of x equals 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus dot, 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 plus alternating element and that. Interval of convergence, negative infinity to infinity. Okay. So we start off with that, and then did you guys basically just plug a root x in wherever you saw an x? Mm-hmm. So if you do that, you'd end up with cosine of square root of x equals 1 minus, I'm going to just simplify, square root of x squared would just give us x, plus, this would give us x squared over 4 factorial minus x to the 3 over 6 factorial plus dot, 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 plus, it's still alternating. When you plug in a root x right here, wouldn't the root x, wouldn't the square root essentially cancel with the 2? So, again, the square of a square root is just the input. So it would be x to the n all over 2n factorial. So again, this is all substitution. And you really could do the interval of convergence with substitution as well. We don't have to really get all that hung up on endpoints because we know that they have to be open, right? We can't ever close on infinity. And so you maybe could think of it as an interval of convergence of negative infinity is less than root x, which is less than infinity. And to get this down into kind of our typical terms, we would have to square everything to get rid of the square root. Well, infinity squared, right? What's that? Just a bigger infinity, if you will. That you can't do. You got to use L'Hopital's rule for that. Infinity times infinity would just be a lot further along, I guess. So you can think of your interval of convergence again as just being infinite. Anyways. Okay. So hopefully that's a pretty cozy one to start off with, a good substitution. And I'm hoping that you'll see number 5 similarly. You guys try number 5? Same question, new function. Did you guys pick e to the x as kind of your base? I would hope so too. So e to the x as a power series is 1 plus x squared over 2 factorial plus x cubed over 3 factorial. And then your nth term is x to the n over n factorial. And so then did you just substitute again? Like Maya was like, hey, are there any other things besides substitution? Definitely, but I'm trying to get you to really see this, to kind of hammer this one home, and we'll move on for sure. So then when you substitute, you get e to the negative x squared, which is what we want. Wherever I see an x, I'm going to put a negative x squared. So it'd be that right there. I'm going to simplify it. Negative x squared would be x to the 4th, positive x to the 4th, over 2 factorial, and then minus x to the 6th over 3 factorial. And then, of course, your nth term, you could simply substitute there as well. So it'd be negative x squared to the n over n factorial. So you could write it as negative 1 to the n, x to the 2n, if you wanted. Of course, that's fine also as an nth term, if you so choose. Let's see here. No. So like this, I don't think so. This is really negative 1 times x squared to the n. So it'd be negative 1 to the n times x to the 2 to the n. So you could go with this. But I think if you did negative x to the, like negative x quantity to the 2n, that would actually take away the alternating element. because your exponent would be guaranteed even, which would guarantee a positive term. So you'd need to split it out like that if you were going to do it. Either way is fine. Just be careful. Let's see here. An interval of convergence. Negative infinity is less than negative x squared is less than infinity. Yeah? Just infinity again? Yeah, it's kind of interesting. Yeah, if you do divide by a negative, you end up with positive infinity is greater than x squared, which is greater than negative infinity. All right, it's kind of the same relationship, just said backwards. And how do you square root a negative number?
You don't.
Right, yeah, so how's that going to work?
I'll just hope it all works.
Just circle it.
Divide by
Do we
zero.
have to think about it? You're just like
Just start dividing by 0 and you're good.
Maybe.
together. Yeah, the math. God's gonna help you. With this dear helping hand.
How do you do the equal?
Well, if you ever run into a conundrum like that and you're just like, oh man, I don't know what to do with that, you know what you always could do, of course. This is intended to be a little review. You could go back and do a ratio test and say limit as n goes to infinity of, and it would be x to the 2n plus 2 over n plus 1 factorial times n factorial over x to the 2n is less than 1. You could just rerun a ratio test, so it should always give you... Say it again? If we're looking for an interval of convergence, it's got to be. Yeah. So then limit as n goes to infinity. Let's see here, it'd be x squared over n plus 1. And so it doesn't really matter what the x is, because if the x is some real number and the denominator is getting huge, which is what's happening, this equals 0, which is always less than 1, meaning that it doesn't depend on x at all. And so I think we could stop right there and say, okay, the radius is infinite, therefore we still go from negative infinity to infinity. So if you ever have one of those kind of like, gosh, how do I do the square root of negative infinity and how's this all supposed to work? You could just always rerun that ratio test. Okay. Hanging in? McKenna said wait. No? Okay, no problem. Okay, so then I think what we're going to, you bet, I think what we're going to see here next is kind of the first application of how these power series could be particularly useful. So if you guys would, take a look at this right here. Hey guys, this is kind of the first time when I would say, if somebody were to say, gosh, why would someone care to know about this? This would be the first instance right here.
I've been wondering that whole thing.
So, yes, that's always a common question.
The entire series, I would like to know.
So I'm about to partially try to answer that question with this one right here. So with this, you're going to find one of the most powerful applications of series is in scenarios where you've got an integrand that is either going to be extremely painstakingly difficult and long to find an antiderivative of, or perhaps no one has thought of an antiderivative for this yet. It's not necessarily the case here, but if you look at this, if you think about all the old skills that we've worked on and you guys are pretty good at, you'd look at this and you'd be like, hey, sure, I could just use U substitution, or Timmy messed up the chain rule, but wait, the derivative of negative 2x, or negative x squared is negative 2x. That means the other factor has to have an x in it, and it doesn't. And so it would be at this stage, you'd run through all the possibilities. You'd be like, hey, should we do some trig substitution?
No.
Partial fraction, not going to work here. Is it ln? It's got to be ln. Can we? All of that is going to fall flat. All the stuff that we've learned, you're going to look at that and eventually come to this idea of like, so either there's a new technique to be learned, or you could just use a series to approximate it and control your error. Does that make sense?
Okay.
So this is actually one of the techniques, if you do take a differential equations class, one of the techniques will be use a series and control your error, or use a series and find the general power series for it and call that the antiderivative, and then have an interval of convergence to say where it does and doesn't work. So from the previous question, we got the integral from 0 to 1, and that series we came up with was, it was 1 minus x squared plus x to the 4th over 2 factorial minus x to the 6th over 3 factorial. So it says use the first 4 terms, so I'm just going to close that off and put a dx right there. And then I'm going to let you guys try to finish this off. So this will be an approximation for this original integral. It's not going to equal it, but it'll give us a decent approximation, whatever decent means.
Let's just crush it, guys. Come on, let's go. I'll do it right now. I don't appreciate it. Just tell me.
Yeah.
I don't know. What difference would that make?
I think I'd be a lot happier. I have more security.
Well, if it was an FRQ, you wouldn't really have to worry about it.
Yeah.
And if the calculator's active, why would we even bother? We could just use Math 9 and run the integral just like that. So
So the max possible error is just going to be the next term evaluated from 0, which is what?
1/3 plus 1/10 minus 1/2.
I know. One is minus 1/3 plus
Yeah,
1/10.
So what?
If you do alternate series, you can alternate series. Which has to be less than equal. So don't we just find the next term?
That's for ultimate. So I like that one better. So would that be?
It does. I don't. Just find the next two. Yeah. So you can cancel that.
By adding all those up by yourself?
9 times 20 is 180. 9 times 4 is 36. 180 plus 36 is? 216.
Yay.
There you go.
I don't know. That's why I was thinking about you plug it into the original or after you take the integral to find your error. Because after you take the integral is where you find the actual sum, the sum. So I feel like you would have to do it to find the error. I don't know.
Do you find the error by integrating?
do you have to enter.
Are you? That's basically what Lenny was just talking about,
Yeah.
right? So, do you calculate the error based on the integrand or the antiderivative? Bless you. So is that
Yeah.
that's basically like at what stage do you use? So, let's see here. What do I want to ask you? What are you actually using to approximate the value of this integral?
Antiderivative.
You're using the antiderivative, right?
Okay, so you have to do the integral.
Yeah, you're using the antiderivative.
So that's x.
You're basically saying that the antiderivative is equivalent to what we're trying to calculate. So I would use that.
What's 24 times 9? So it's going to be 240 minus 24, which is
So that's
2.
180, 9 times 4, 46, 216.
This is, of course, this is one of the beautiful things about a power series. Is essentially just a polynomial. They're very easy to find the antiderivative of. So here we'd get x minus 1/3 x cubed plus 1/10 x to the 5th minus, that'd be what, 1/42 x to the 7. Evaluator from 0 to 1. And of course, also what's nice about this is our centering point is 0. That's one of the limits of integration. The other one is 1. But the nice thing, of course, is you plug a 0 into something like this, you just get 0. So this would then equal 1 minus 1/3 plus 1/10 minus 1/42. We're going to say that that is approximately equal to this original integral. Make sense? Okay, so then, like Darian was like, what do we do with the fractions? I just leave them like that, right? There's no reason that we'd have to do anything beyond that. If you wanted to, you could, but I'm going to leave it alone. You guys have any questions at all? We need to talk about the error a little bit, but it's going okay? Okay. So I think as far as thinking about the error, this is really important. We're basically saying that series, that pattern of numbers added up, is approximately equal to the integral that we were supposed to find. So then when it comes to bounding the error, finding the maximum error, we need to really judge carefully what that series is. That particular series, like, what's the most important thing about it? It's alternating, right? It's alternating, and it's okay at this point in the game to say, you know what? This is a converging alternating series, right? We can see those terms are decreasing in absolute value towards 0, right? 1, 1/3, 1/10, 1/42, ... And it is an alternating series. So I would say something like this. This, referencing what we just have there, is a converging alternating series. So max error is less than or equal to the first neglected term. So that's that absolute value of the first neglected term. Yep. So I was going to show you some symbols here in a second, but that's the concept. We're looking for that first neglected term. So as far as notation goes, we were talking about that over here. You can maybe do something like this. Absolute value of the integral from 0 to 1 of e to the negative x squared dx minus the integral from 0 to 1 of, maybe if we called that previously like p sub 6 of x, that would be our, it was sixth degree before. So the little subscript should always go with the degree. So again, I didn't really label it as such, but I'm saying if maybe we had labeled that as, hey, this is P sub 6, the power series, 6th degree power series, something along those lines. Kind of the issue here is we have no idea what that first neglected term is, do we? We've got to figure it out. So we go back to this stage right here, and we need to figure out what that missing term was. Wouldn't it have been plus x to the 8th over 4 factorial? So then if you do the antiderivative of that, that would give you, what, x to the 9th, and it would be 9 times, oh, there's your 9 times 24. There we go. So 216, which means when you plugged in a 1, you'd get 1 to the 9th over 216. So I would say that your error is bounded by 1 over 216. So the error will be at most 1/216th. And if you want to, you could go back and you could use your calculator and you could figure out exactly what this is, and then you could figure out what the value was supposed to be. Find the difference. I think you'd find the difference would be less than.
That is 26 35ths.
26 what's?
35ths.
26 35ths?
Or 0.7428.
Okay, so then calculate the actual integral, math 9, 0 to 1, e to the negative x squared. Find the difference between those two, and it should be less than 1/216th off. While he's doing that, can I ask you guys a question? Why didn't I use the Lagrange error bound Because we just zeroed right in on the alternating series error bound. Why not the Lagrange? Because that one is hard.
It's so scary.
It's a little harder. Did you know? Yeah, so alternating, so McKenna's point is well taken. If you've got an alternating series and you've got to calculate the error bound, use the alternating series error bound because not only is it easier, it applies, right? Lagrange applies to pretty much all the series. So we could have used Lagrange here. We would have only been able to go out to the 7th and then correspondingly the 8th degree. We would have been a degree less. So it could have changed things somewhat, I suppose. We would have needed more information too because we really don't know anything about the, I guess, well, you know what? We actually could have calculated the 7th derivative. Not the most pleasant thing. And so for a lot of reasons, I think alternating series error bound was the better choice. Did the numbers play out?
Yes,
Yeah.
it was, so the difference was 0.00397 and 1/216 is 0.00463.
Pretty darn close, wasn't
Yeah.
it? So that's like a pretty tight error bound, down to the 10,000th-ish. Okay, that's cool. Good deal. Any questions? Did you guys navigate that okay? It's fantastic. Sean?
So for like notations, like, is it P6 or P4?
So what we did, the reason why I chose P sub 6 is we used a 6th-degree power series
Yeah.
as kind of our substitute for e to the negative x squared. And so I'm saying that I used, that's what I'm trying to say here, is that I used that. Why were you thinking 4?
It's like it's the
Oh, first 4 terms?
Yeah.
So that subscript typically goes with the degree.
degrees.
Yeah. Yeah, so first 4 terms, really honestly, the first, depending on the power series, the first 4 terms could be like the 100th degree,
Oh.
right? Depending on what's been substituted or whatever. And so that's kind of the standard practice to use degree there. What's hard is if, like, one question says use the first 4 terms, and then the very next question, it's like a whole different question, but it says use the 3rd degree,
Oh.
right? So you got to pay close attention to what's asked. And I think the AP folks, and I try to follow suit with this for the most part, they're typically going to say use the first 4 terms, use the first 3 terms. They're going to reference the number of terms versus degree instead of like going back and forth, back and forth.
Yeah.
But I think you'll see, like, if you looked at your website, I think there are times when it goes back and forth. You just got to read carefully. Yeah. Anybody else with a question? Okay. So, take a look at number 6. Maya, you can breathe a sigh of relief. Yes. You guys wouldn't mind? Check it out. Number 6 says, right, the first 4 terms in the general term for the power series, f of x equals that. Include the interval of convergence. So same directions, but this should spur some somewhat different thinking, perhaps, than what we've been using up to this point. So please do check that one out. As your base series? Yeah. I'm hoping that the reasoning would be simply that this looks a whole lot like it. You know, the function looks a lot like that. So 1 over 1 minus x is equal to 1 plus x squared plus x cubed plus ... plus x to the n. Interval of convergence is right there. And yes, I'm going to keep trying to put these in front of you to give you more and more of a chance to get them memorized. There it is. So then when you look at the function and you try to compare it to our base, you know, hopefully you notice, like, man, these look the same except for what? The x. So the x has been multiplied, right? So if we were to say, all right, if I'm just going to go times x, I can absolutely do that as long as I do the same thing to the other side. Multiply the left side and the right side by the same thing. We're not breaking any algebra rules, and so we're okay. So then we could say x over 1 minus x would then equal x plus x squared plus x cubed plus x to the 4th plus ... plus x to the, are you guys okay with n plus 1?
Yes, sir.
Okay. So you starting to see this okay? So let me just give you a little bit of something to think about. As we move forward, one of the things that we're going to do is this. This one was not like this, but can you imagine a question like this where, you know, perhaps it's multiple choice. To me, that's the most logical way to approach this. But what if I gave you this in the purple box and said, hey, what might the function be that would generate A power series like that. So kind of backwards, right? So take something that somebody has already messed with and say, how did they mess with it and what did they mess with, right? So just something to think about here, like if you did have that with this one, here would be an approach that you could take. You could notice that every single one of those terms has an x. And I like this idea of factoring out. So when you did that, of course, you'd get this. And, maybe at this point, especially if it was multiple choice, I wouldn't get too worried about the nth term. You'd say, oh, I get it. It's x times, and I know that this is just the geometric series, and so you'd be able to go backwards. So we want to be able to do these forwards and backwards. That's why we're going slow, and we're really trying to talk about all the details, like why is this, why is that, and all those sorts of things. Still doing all right? Okay, so how about number 7?
No, but then you do the over, yeah. So the denominator.
Yeah, 1 plus x minus x gives you
Oh,
1 plus x
squared.
which is different squares.
1 plus x over 1 over.
The problem is, though, is it's 1 plus x or 1 plus x.
Present one way, but I think there's at least 2 other ways, maybe more. So here was my thought. I'm definitely going to start off with this, right? Yes, does this make sense? Okay, so we're going to start off with that. Of course, it's this. I'm not going to write the nth term at this stage. I don't know. I don't think I will. So I'm going to just say that plus ... I know that it keeps on going forever and ever. And then here maybe be one way of doing it. Couldn't you look at this? I'm just going to ignore the numerator for a second. Couldn't you look at this and say, oh, somebody has just replaced all the x's with x squareds? That's reasonable. So let's do that. So if I write this out, 1 over 1 minus x squared would have a power series of 1 plus x squared plus x to the 4th plus x to the 6th. Just replaced all of my x's with x squareds. So that's gotten me there, but then how is my goal still different from that? Like, what would I do?
Multiply times 1 plus x.
Yeah, I could just multiply the left side and the right side by 1 plus x. Since it's an equation, I can do that. So it'd be 1 plus x. Maybe I'll just write it like this. 1 plus x. So that would give me the thing I want, 1 plus x over 1 minus x squared. And then as I distribute this, it would be 1 plus x times 1. So that would just be 1 plus x. And then 1 plus x times x squared, which would be x squared plus x cubed, right? Starting to get kind of a curious pattern here. And then if I get this one in there, so 1 plus x times x to the 4th would just be x to the 4th plus x to the 5th. This is feeling really familiar. X to the 6th plus x to the 7. We're starting to get the point here, I think. Isn't this just what we started with? How is this possible?
Magic.
What if we did some good old Algebra 1 and we took this and we said, you know what? That denominator is the difference of squares and it's factorable and therefore potentially could get some cancellations. F of x is essentially just the geometric series, yeah.
So basically we just multiplied 1 over 1 minus x times 1 plus x over 1 plus x,
Mm-hmm,
which is technically just 1, which is not
Mhm.
the same thing.
mm-hmm,
So we just got the first 4 terms.
mm-hmm.
So it's just the same.
Yeah, so that's another way you could do it. So I substituted, then multiplied. You could multiply and then substitute. So, or you could have just seen that and be like, hey, look, it cancels, and it's the thing that I already had memorized from class. So, anyways, still just kind of trying to manipulate these and mess with these.
Cool.
Doing okay?
Yep.
All right. I think the next one might twist you up a little bit. We'll see. Number 8. I have definitely tried to, tighten things down to the point where I don't think there's any way you could do. I think that I'm trying to I don't think the wording is ambiguous, right? So it says, write the first four terms in the general term power series centered at C equals 0. So no changing the centering point. And it's got to be a equivalent power series for that function right there. Okay, so give you a few minutes, see what you. So my first thought was, you start off with this geometric thing, 1 over 1 minus x, and I'm hoping that at this stage, after all the times we've written this, we are all absolutely rock solid with this geometric series. So then the first thing I notice is it's plus, not minus, right? And so I'm just like, that means I'm going to need to substitute a negative something in there for x. The 3 bugs me as well. So here was my thought. You might have done it differently and you might have been successful. We'll find out. I decided that I would substitute that in for x. So this would give me 1 over 1 plus x over 3. Make sense? So I'm not there yet, but at this stage it would be 1 minus x thirds plus, it would be x squared over 9 minus x to the third over 27 plus ... plus negative x over 3 to the n. Is this making sense so far? So then here was my thought, and I don't know, I don't have memorized what you wrote, Sean, but here's what I was thinking. This gives me 1 over 1 plus x over 3. So I could actually get the x in the numerator and deal with the fraction in the bottom in one step. If I multiplied this by x over 3, that makes sense? That would give me x times 1, which is just x. And then 3 times 1 is 3. And then the 3's would cancel here, giving me what I want. I'm still centered at 0. But then I need to multiply the right side by that 3, or by the x over 3 also. So that would give me 1 times x over 3. And then x over 3 times x over 3 would be x squared over 9. And it would be plus x cubed over 27 minus x to the... What did I do here? Over 9. Oh, yeah, x to the 4th over 81. The numbers were just kind of turning sideways on me there for a second. Then it would be plus ... plus, so it'd be negative x over 3 to the n times x over 3. We could simplify that a bit. But at that stage, I've got the first 4 terms right there. Does that make sense? First 4 terms. Sean, do we end up with the same thing?
So I have 1 minus 3 over x.
1 minus x over 3 or 1 minus 3 over x?
3 over x.
How did you get 3 over x?
I just substituted negative.
Didn't you substitute negative x over 3 or did you substitute negative 3 over x? I'll have to think about that. I don't know. I'm not saying that it's just for sure wrong. I'll have to think about that. I don't know. Honestly, don't know. I'll look at it some more. Does this make sense? I think I can definitely defend this for sure. So then as far as an interval of convergence goes, let's see here. Our nth term would be negative 1 to the n times x squared. It'd be x to the n plus 1 over 3 to the n plus 1. I think you'd find that your interval of convergence has definitely changed because of the 3. I'd be willing to bet that your interval of convergence is negative 3 to 3 with possible closeds on those. You'd have to test your endpoints. So certainly be cautious about that. So I think that's a really good place to stop. Yeah, I think we're in a good spot. I don't think we'll finish everything tomorrow, but I think we'll come pretty close. Okay. See you guys tomorrow. Have a great rest of your day.